And welcome everyone to Learn a Trade. This is Kevin Tate. Today's lesson is a continuation of the Bunn Brewer training. This lesson will be proceeding with the dual and the dual SH models and the single SH models. As you can see in the display, we're going to start off with the going over the bypass valves. And by the way, for those who may not be fully aware, the bypass valves are located in the upper portion of the machine up top, and you'll see it a little closer view as we go on. Location: the bypass valves are located on the spray head panel inside the hood. That's this section right in here on both sides. As you see, you have two sides. So this is why they call it a dual um, brewer. Now we're going to go into some of the test procedures. First, disconnect the brewer from the power source and place a server beneath the funnel. Check the water level in the tank to confirm that it is within a half inch from the top of the tank. Connect the brewer to the power source. Check the bypass valve for coil action. Place the on-off switch in the on position. Press and release the brew switch. Listen carefully in the vicinity of the bypass valve for a clicking sound as the coil magnet attracts and repels the plunger. Disconnect the brewer from the power source. Now let me just give you a quick tip on this. This is the Bunn manufacturer testing procedure. Um, but right over here, this is the actual image of the bypass valve. This is how it looks. But another thing that you can do as you go through this testing procedure, when you do press that brew switch, as they tell you to press the brew switch and then listen for a clicking sound, you can do all of that. But the another tip to that is this is electromagnetic. This is a magnetic coil, so it's going to, once the electricity uh, op- um hits it, that valve activates, and then it pulls up the plunger, pulls that plunger up. So when it is activated, you should get a pulling sensation. So what you can do is, a lot of times you can test these coils by taking a flathead screwdriver and just placing your flathead on this, uh, just on the tip of this metal portion right here, the bracket, this metal bracket, and you will feel that that plunger is activated. You'll be able to tell because it'll pull in your screwdriver, the flat piece, the flathead section of your screwdriver. It'll pull in, and you'll be able to pull it off, but you'll feel the resistance there. So that's just another tip that you can use that as a testing procedure along with this here. If the sound is heard as described, there may be a blockage in the bypass valve or the water line to the spray head. Remove the bypass valve and inspect for wear and remove waterborne particles. If the sound is not heard as described, proceed to number 6, which is up here, to connect the voltmeter lead ends to the bypass valve, to the two terminals that you've seen there, these two terminals. Connect the brewer to the power source with the selector switch in the 1 or 1.5 gallon position. Place on-off switch in the on position. Press and release the brew switch. The indication must be 120 volts AC for 2-wire 120 volt models, 3-wire 120 208 volt, and 3-wire 120 to 40 volt models. 200 or 240 volt AC for 2-wire 200 or 240 volt models. Disconnect the brewer from the power source. If the voltage is present as described, but no coil action is observed, nor clicking heard, bypass valve is defective. Replace the valve and test again to verify repair. If voltage is not present as described, refer to wiring diagrams and check the brewer wiring harness. Also, check the control board for proper operation. Removal and replacement. Remove the wires from the bypass valve. Drain enough water from the tank so bypass valve is above the water line. Remove water lines from bypass valve. Remove the 2 nuts retaining the bypass valve inside the hood, and remove bypass valve. Remove hose, barb fitting, and attach to new bypass valve. Install new bypass valve with hose barb fitting. Reconnect the water tubes and the wires to the bypass valve. Refer to Figure 2 when reconnecting the wires. If one of the terminals is marked I, connect white green wire to it. So you see the I right here. That's on that left side terminal. That's where you would connect the white green wire. So it's a white wire with a green line. You would connect that to that terminal, and then the white violet wire to the selector terminal. So this terminal here is for the dispense valve. This terminal here is for the brew selector. Now we're going to go to the selector switch. The location of the selector switch. The brewer selector switch or switches are mounted in the front panel of the hood, right up here. These are your selector switches, right and left side. Right here, you have the water faucet. Test procedures. These are for early model selector switches. A lot of the newer models now are touchpads, but these are the earlier models. So first, disconnect the brewer from the power supply. Separate the connector on the selector switch harness from the brew timer circuit board. Carefully slide the plastic cover off of the connector from the switch harness. Excuse me. Check for continuity across the pink and tan wires on the connector. When the switch is in the small batch position, continuity must not be present in any other switch position. Check for continuity across the pink wire and gray wire when the switch is in the medium batch position. Continuity must not be present in any other position. Reattach the connector to the brew timer circuit board. Disconnect the gray wire from the left or right selector and the gray wire from the interface socket. Check for continuity across the gray wires. Reconnect the gray wires from the selector switches and the interface socket. Disconnect the pink wire from the left or right selector switch to the grinder switch. Check for continuity across the pink wire and the terminal on the grind switch. Reconnect the pink wire to the grind switch. Disconnect the tan wire from the left or right selector switch and tan wire from interface socket. Check for continuity across the tan wires. Reconnect the tan wires. With the selector switch set at the medium and large batch positions, disconnect the white violet from the bypass valve. Check for continuity across the white violet wire and terminal on bypass valve. Reconnect the white violet wire to the terminal on the bypass valve. Disconnect the white wire from the dispense valve. Check for continuity across the white-red wire and terminal on the dispense valve. Reconnect white-red wire to the terminal on the dispense valve. If continuity is present as described, the switch is operating properly. If continuity is not present as described, replace switch assembly. Removal and replacement. Disconnect the connector on the selector switch harness from the Brewer timer circuit board. Disconnect wires from the selector switch interface socket. Disconnect valve and bypass valve. Loosen the set screw on the switch knob. Remove the 9/16 nut and washer holding the switch to the hood. Remove the switch. Install the new switch. The positioning tab must be in the hole in the hood for proper switch and knob alignment. Install the knob so that the arrow lines up in the large batch position. When the switch is turned on, the full right position, when the switch is turned on to the full right position, reattach the connector to the brew timer circuit board. Refer to figure 4 when reconnecting the wires. Now this is your brew selector switch. And these are the wires, so you'll be able to follow along with those if you ever have to change one of these. There are, in my area, there are in the Northeast, there are not a lot of these models out now. The older models, there's not a lot of the older models out. There are a lot of the newer models out, but I would like to go over all of the models in this members section. So bear with me if you are familiar with most of these testing procedures and stuff, but there are other members that are new to this, and I would like to go over all of the models that we all may run into. So here are all of those all of the wiring coming off of the selector switch. These wires here go to the timer, and these wires here, the gray and the pink that they were talking about, and the tan, they're all going to, these three are going to the interface socket. And these here, the white red wire goes to the dispense valve, and then you have your white violet wire that goes to the bypass valve. So you'll be able to, go back to this and look at it again. And then also you all have access to the service manuals in our manual library also. And this right here is the late model selector switch. They're just showing you it's the same type of wiring, but it's different configurations. And now they're just going over testing procedures for the late models. So I'm going to go through that real quick. Test procedure for late model selector switch. Disconnect the brewer from the power supply. Disconnect all wires from the brew selector switch. Check for continuity across terminals B and 1. When the selector switch is in the small batch position, continuity must not be present in any other switch position. Check for continuity across terminals B and 2. When the selector switch is in medium batch position, continuity must not be present in any other position. So this is why they're checking these terminals here, because these switches, when they malfunction, they will get stuck in one position. So say like if someone does a medium batch and then the next time they do brew a batch, they brew a small batch, so they turn the selector switch, but the contacts within the selector switch end up sticking. So then you have continuity. You're trying to brew a small batch, but the continuity is in the medium batch. So then it won't brew properly. It'll probably brew over the amount that you wanted. And then here they're going over the circuit breakers, which are right below on the inside panel there, the inside front panel. The location. The circuit breakers are located on the low front of the brewer, mounted on the server platform, just above the spring contact receptacle assembly. This is that spring contact receptacle assembly. And these are the circuit breakers. Test procedures. Disconnect the dispenser from the power source. Remove the wires from the circuit breaker. Check for continuity between the terminals. Continuity must be present between the terminals. If continuity is present as described, the circuit breaker is functioning properly. If continuity is not present as described, press reset button and repeat step 3. If continuity is not present as described, replace the circuit breaker. So this is these are resettable circuit breakers right up here. So when you remove those wires, you'd have to disconnect those wires from the back side. So you have to remove these 6 screws just in case you weren't aware of it. And then you would have to open up that panel. That panel will slide out for you so that you can get access to the wires here. You'll remove these wires, and then they want you to test across the terminals. And if you don't have continuity, then you could reset. You can just press in the front button on that. It's right on the front section here. Just push that in and it should reset. If it doesn't reset, then you would have to replace the circuit breaker. And here is the contactor assembly. The location. The contactor assembly is located inside the hood, just to the rear of the dispense valve, right side for dual and dual SH models. Okay, so it's up here inside the hood, just to the rear of the dispense valve. So right back here on the right side, and that's for dual and dual SH models. Test procedures: mechanical thermostat, Brewers with or without recovery booster. Disconnect the brewer from the power source. Disconnect the white wire of the 2-pole 120-volt terminal block. White wire of the 3-pole 120 208 volt or 120 240 volt, or the red wire of the 2-pole 200 or 240 volt terminal block, and the black wire of the contactor coil. Disconnect the black wire of the control thermostat from the remaining black wire of the contactor coil. Gently remove the capillary bulb and grommet from the tank. With a voltmeter, check the voltage across the white wire from the terminal block on 120 or 208, 120 or 240 volt units, or the red wire from the 200 or 240 volt units, and the black wire from the control thermostat. When the thermostat is turned clockwise to the full on position, connect the brewer to the power source. The indication must be 120 volts AC for 2-wire 120 volt models. 3-wire 120 208 volt models, or 3-wire 120 240 volt wires models. B, 200 to 240 volt AC to 2-wire 200 or 240 volt models. Disconnect the brewer from the power source. If voltage is present as described, proceed to number 6. If voltage is not present as described, refer to the wiring diagrams and check the brewer wiring harness. Number 6, check for continuity between the two black wires of the contactor coil. If continuity is present as described, reconnect one black wire to red or white wire from the terminal block, and the other black wire to the black wire from the controlled thermostat. Reinstall capillary tube into the tank to a line 7" above the bulb and proceed to number 7. So what they're saying is when you reinsert that bulb, that capillary bulb from the thermostat, you want to go about 7" above the bulb, and then you can proceed on to the next step. If continuity is not present as described, replace the contactor. Step 7. Locate the white wire or red wire on L1 terminal and black wire on the L2 terminal on the contactor. With the voltmeter, carefully check voltage across the white wire, the white or red and black wires. The indication must be 120 volts AC for 2-wire, 120 volts models, 200 volts AC for 3-wire, 120 to 208 volt models, and 240 volt AC for 3-wire, 120 to 40 volt models, 200 to 240 volt AC for 2-wire, 200 and 240 volt models. Disconnect the brewer from the power source. If voltage is present as described, proceed to number 10. If voltage is not present as described, refer to wiring diagrams and check brewer wiring harness. Number 10. Check for continuity across the terminals on the left side and the contactor by manually closing the contacts. Continuity must not be present when the contact is released. 11. Check for continuity across the terminals on the right side of the contactor by manually closing the contacts. Continuity must not be present when the contact is released. If continuity is present as described, the contactor is operating properly. And I'm going to end this session here. I'm trying to keep these at least 30 minutes or so. But the next lesson, I know this was probably a lot to take in because we're going over 2 different models, but they're the same units, but they're 2 different models. And these are the early models. But we'll get through this and then we'll move on to some of the newer models after we get through this session. The next session, I'm going to start with the contactor assembly. So we'll be going over those contactors that they were just talking about in the testing procedures. So I appreciate your time. I thank you. I hope this is helpful. I hope you're able to go back to it and go through a few things. If you have any questions, please feel free to email your questions to me, and I will do my best to get you the answers for them. Take care, everybody. Thank you. We'll see you on the next one.